When we're talking about algorithms in MATLAB, one of the most important things to talk about is how fast do they run. And one of the ways to measure that in MATLAB involves these two words, tick and tock. So I just typed in tick, and you should think of that as starting a stopwatch. And now when I type in tock and I evaluate it, MATLAB tells me how much time elapsed from when I started the stopwatch until now. So if I type tock again, it's still going back to whenever I had typed tick. If I type tick again, and now I type tock, so you can see that typing tick, that started the stopwatch over, and it was 3 seconds between me typing these two. And one other thing I can do with tock is I can write something like y equals tock. Okay, and then instead of printing out this line of English, instead I just get the numerical value for how many seconds elapsed. And that'll be really useful if we ever want to plot how much time some algorithm takes for various inputs. So let me test out this tick and tock. And if you want to test it out carefully with some code, you really want to do it in a script or in a function, because otherwise if I do it in the command window, it's also measuring, for example, how long it takes me to type it. So in this case, I'm going to do a script, and I want to measure how long it takes for a program that I write that's supposed to search a vector for a specific number. And I just want to choose a random looking number. I'm going to search for the number 13. And I'm going to search through a vector that's about length 10 million. So let me make a vector of all ones of length 10 million. And the reason I do that is because I want to have some vector where it's not going to be too easy for my code to find the number 13. So I want to have some control over where 13 is. So that's why I'm choosing a specific vector instead of choosing a random vector. So now let's put a 13 into V. So I start with these 10 million ones, then I put a 13, then I put 10 million more ones. So total, this is length 20 million and 1. And now comes the part where I'm going to time the code searching this vector v for this number 13, for this number z. So I'm going to start the stopwatch with tick. And even though I've typed it here, that doesn't actually start it. It won't start it until I evaluate this script in MATLAB, and it goes through this line by line. So then when it gets to this line 4, when in the evaluation, that's when the stopwatch will start. So b, this is going to be a true-false value, a true-false variable. I start out assuming false, the value z isn't in the vector. And then I'm going to search through the vector for x equals v. So what that does is it goes through every element in v and sets it equal to x one at a time. Then I'll say if x is equal to z, so if it finds it, then b equals 1. Then when the for loop is done, I stop the timer, tock. I could either have a semicolon or not have a semicolon after tick and tock. Doesn't change anything. And then let's display b just to make sure I did it correctly. So because the number z does appear in the vector v, I want the eventual answer to be true. I want b to be 1. So let's save it. I'll call it, how about timing? Now let's come back to the command window and run it. I type in timing. I don't need any parentheses after it because this is not a function. Okay, it took about 0.26 seconds. You'll find a lot of times if I had chosen something smaller, like say I chose 10,000 instead, or I guess this is 100,000 instead of 10 million, how long will it take? Okay, then it takes a lot less time. If I choose a bigger number, So here's 100 million. Okay, this is going to take more time. And you can see that it grows very linearly with how long the vector is. So the one that was on the order of 10 million, that took about 0.27 seconds. When I made it 10 times longer to on the order of 100 million, then it took 2.65 seconds. So it got multiplied by about a factor of 10. And if we aren't going to work with the technical terms about growth, like using big O notation and talking about polynomial time or exponential time, but it's good to know that those terms exist, and if you ever take a class specifically devoted to algorithms, those are the sorts of things you're going to work with a lot. And why do we care about this tick and tock? Well, one of the big things we care about is, can we make our function faster? Can we make the code that we write faster? So there's one obvious way to make this code faster, and it's to put a break after the b equals 1. And the intuition behind that is, once I find the value z, okay, then there's no reason to keep going through the vector. Once I've found it, then I know the total answer is true. So let's try running the code again, this time with that break inserted. And let's see how long it takes. So it took about exactly half the time. And why is that? Well, it's not because putting in break cuts the time in half. The reason is that the 13, it appeared halfway through the vector. So by having this break, that saved half of the vector from us having to search it. Another thing to mention is that it wouldn't have made sense to have the word return here, even though when we talked about them before, break and return worked very similarly. But here it's not a function, so there's nothing to return. Scripts don't return anything, so that's why I had to use the command break.